Morning. I have one very important thing to do before I start. Which is check that my clicker's working. Oh, it is. It was just slow. Last time I gave a talk, the buttons were reversed. It's incredibly surprising how difficult I found that to deal with. So let's see if we can keep this moving in a forward manner today. Good morning. Thanks for coming. I'm painfully aware that there are other excellent talks in this slot, so I'm excited that there's anybody here at all. I'm really glad you are here because I think this is a super interesting topic and something that is changing my working practice in lots of ways. So I'm very excited to be here. I'm very excited to share it with you. My name's Lorna. I'm a developer advocate with a company called Nexmo. We do communication, APIs. We're in the middle of rebranding to Vonage. My whole slides say Nexmo because my mouth will also say Nexmo. I will be working on this in the break between conference seasons. So, can I just get a quick show of hands, and I promise not to do this too many times. Who has already heard of Nexmo? Okay. That'll be the 3 people I was talking to in the bar last night. Awesome. So why am I here speaking about OpenAPIs and about OpenAPI in particular? I think APIs are so key to the way that we develop software today. Whether we are integrating with third-party APIs or whether we are connecting our components within our own applications. There's a whole lot of API calls going on. I'm speaking mostly about HTTP APIs. By using API descriptions like OpenAPI, we can really power up and enable our API workflows. So today I want to tell you about OpenAPI and show you some examples of what you can do with it, how it's changed things for us, how this glue of inter-application communication can really come up to the next level and how the tools can help us in our technical practice. The big thing that I feel is enabled by API descriptions is spec-first API design. I've been on the conference circuit many years. I've been working in APIs for many years. And I used to give a talk about docs-first API design. Once upon a time, not that long ago, I guess, really, I went to work to discover that a client for whom we ran an admin back-end system with a web interface, they had a marketing website which had some read access to some views on the database. I had a ticket open saying, please grant read-write access. So I started with no, and moved quickly on to what problem are we really solving? What is this the solution for? And they wanted to take some tentative bookings from the front end through their marketing website, which is completely reasonable, and the deadline for this was yesterday. So, I swiftly wrote some API documentation and circulated it to their team. Now, what's cool about doing docs first is it involves all of your stakeholders. So even the people who can't create or use an API, product people, tech project leads, delivery managers, can all interact with documentation, right? It's aimed at humans. Also, as an engineer, when I took my writing hat off, put my engineer hat on, it was a really small company. When I came to build the thing, I've never built something so quickly because it was so well described already. Fast forward 5 years, and spec first gives me all of this and more. By creating an API description, I can generate documentation, I can involve all the stakeholders. Everything that was true about docs first is true about spec first. But I can also generate a mock server, the stubs of the API that I'll publish, the SDK for the different tech stacks that we need to consume this thing. And I can do it all off a single source of truth. And whether you're designing a new API or just adding a feature, leading with the spec allows everybody involved with the project to interact with it in a way that makes sense to them. I do generate the docs and share it with the product people. The engineers use that as well. But when I'm really thinking about the API standards and whether we want to accept the patterns that we're proposing in this version of the spec, I spin up a mock server and I poke at it with my favorite HTTP client, exactly as I would as an engineer. Like, what's this going to be like to use? What does it really mean? I'm often asked whether OpenAPI is appropriate for existing APIs, or if it's something that really you should lead with on your next new project. So new APIs, existing APIs. My advice is yes. At Nexmo, we are a mix, so we retrofit the OpenAPI descriptions on all of our existing APIs. That isn't always easy. OpenAPI is pretty modern and awesome, so if you have gnarly, terrible legacy API practices, you'll find it hard to use OpenAPI in places. It's like a code smell, except it's a spec smell. Not really sure what the analogy works there. But for new APIs, for new features to existing APIs that you've gone to the trouble to describe, it's incredibly valuable. So I am yes and yes on this question on both sides. Today is about OpenAPI. It's not the only game in town. So if you have heard of API Blueprint or RAML from MuleSoft, who I think now have OpenAPI support, or OpenAPI, I think a lot of these principles still apply. Spec-first design still applies. Using your spec as your source of truth still applies. The syntax looks different. The tooling is different. If you have used an older API description protocol called Swagger, this was donated to the community. There's a foundation, it's a Linux Foundation project. We have people set up to look after it, and they are individuals from all kinds of organizations, some not from an organization at all, some from big organizations, some from small organizations. So we have a raft of people looking after this open standard, which has had a new release, version 3. It's not that new now. It hasn't been called Swagger for about 4 years. Please try to keep up. So OpenAPI, that well-known open standard. And the thing about an open standard is we are all free to participate in that, to see what's going on inside it. The issues are public, the meetings are public, there are Slack channels, you can find out what's going on. And I think the openness gives all kinds of organizations confidence in adopting something like this. It doesn't belong to a company. The standard won't suddenly change to match one corporation's priorities, because nobody really has that critical mass. It's owned by all of us, and the open standard leads to some excellent open tooling. You want to build a tool, you're welcome to do that. And that gives us choice, it gives us competition, it gives us solutions available in all sorts of tech stacks, including some I had no idea we needed. But somebody did, and that's the point of having it open like this. I'm going to speak now about some of the details of OpenAPI and how it looks. Maybe some of you don't love slides and slides of YAML. But some of you need to know how the engine works before you can drive the car. We all have different learning styles. So if you need to know how it works, the next 5 slides are for you. If you don't want to look at 5 slides of YAML, why don't you just tweet what a great time you're having and come back to me in 5 minutes, okay? Fantastic. All right, this is the top section of an OpenAPI spec. You can use JSON or YAML. This one is YAML. I could argue passionately for or against JSON or YAML, right? There are no really good solutions. This is designed for machines, not for me. We use YAML. It doesn't annoy me at all. I think sometimes the Git diffs are a bit tidier. It's my best So we've got OpenAPI, the version of the OpenAPI specification that we are following. The servers, array. So if you have multiple endpoints for redundancy, for sandboxes, for geographical reasons, cool, list them all here. Now we have the info block. It's very easy to skate over the info block. A lot of the tooling doesn't necessarily render it or doesn't render all of the fields. This is a real OpenAPI spec. If it wasn't, it'd be more perfect. I haven't quite got to just fixing everything that I want to use in a slide deck. I have a to-do list after seeing this one. So this is our number insight API. It's Nexmo's simplest API. You give it a phone number, and it tells you if the phone number is valid and how it should correctly be formatted. And we also have basic, standard, and advanced levels, which give you increasingly more details for increasingly higher cost, and it's like fractions of pence. So now you know everything about this API, it's easy to understand. The info block is important because someday, not too far in the future, we are going to do more than render documentation from our OpenAPI descriptions. We are going to upload our spec files to directories and catalogs. Users will discover our APIs this way. They will be looking for something, and they will come to find what we have to offer. And just like your projects and your websites and everything else, that only works if the metadata is there. So take the time with the info block. Lots of people, just like on GitHub, we see people searching with a specific license. Right? The same for this. Get all of this data in the right place and make sure it's complete, because we'll be using this, especially the keywords and the description that I cut off horribly because I didn't want to make the font any smaller than this. And if you're a long way back, I still feel like I owe you an apology, sorry. So this is the top part. These top level elements, OpenAPI, servers, info, will be present in every OpenAPI spec file. The next element is called paths. Now, I've ripped out the guts of this to just give you an outline of how this works. You're already starting to get the impression that these files might be reasonably long-winded. I'm not going to lie, they're thousands of lines of YAML usually. This one is at least hundreds, and it's the smallest API we have. We have the paths element. Within paths, we list each of our endpoints, and there can be variable parameter placeholders in there. You can see it here with the format. And then we list which verbs this endpoint supports. It's just a lookup service, so it's not that interesting. But that's what that get is doing. Every operation has an operation ID. Name your operation IDs carefully. They get used in the most unexpected places. Obvious places, like you'll see it when I show you the docs stuff later, that it's used as the internal hyperlink name. Cool. It can be also used as the method naming and generated calls and that kind of thing. So just try to give it a unique tag that's going to mean something to you in any context. Just be a little bit careful with that. Within each of these individual paths, each operation, we'll also have parameters. So these are the either body or query parameters that we're going to supply to this particular API call. You'll also see responses. So here we can detail the status codes that might be expected for each of those, the content types that might be expected, and then the details within each of those. So it gets quite long-winded, but it's very, very descriptive. Every aspect of your API is described here. Another thing worth mentioning, in addition to parameters and responses, is that you'll also see callbacks. So if your API call, for example, the third one down, advanced async format, you give the parameters and a URL you'd like the results to. Don't call it synchronously, it basically always fails. Call it asynchronously, and then as a result, you'll get a payload back. And that's documented as a callback operation within the OpenAPI spec. We don't yet have support for incoming HTTP requests that are triggered by something else, where you don't subscribe or perform the event that makes it happen from inside the API, but there's an open proposal for it, and some of the tools have support already. So if you're interested in webhooks, callbacks, OpenAPI stuff, please talk to me about that. I'm working on a proposal, so if I understand your use case as well, this would be a great time to talk to me about that. Is there anything else I need to tell you here? No? Okay, so let's look at one of these in detail. Here's the basic call. There's parameters, and there's responses. The parameters, we have format, we have number, we have country, and you will immediately notice that there's no details here. This stuff is a pointer to another location. This is one of the magical pieces about OpenAPI, particularly for someone who's had experience of writing markdown documentation, and there's a lot of copy-paste if you have to generate all this stuff by hand. This is compiler-assisted, if you like. The generators will go and look this stuff up and bring the details in when they need them. So OpenAPI supports this reference, and you can ref to other sections of the same spec, and you can ref to sections of other files. So if you have a few APIs that share common, for example, we share common error format between our newer APIs, or if your file is just too large, which is not that unusual, then you can ref out. So that's parameters. Here's responses. You're going to get a 200 response with an OK, and the content is going to be either JSON or XML, and the responses are described, again, away in a ref. I think there's a style question here when you write an OpenAPI spec. Should you always use a ref to keep things tidy so a human could read like a whole endpoint in one screen? Should you only use the components section or another reference when you reuse a variable? I don't know the answers. We're about to work on a style guide, but I feel like there's a lot that we haven't settled the conventions yet, and the answers probably depend on your use case. All right, one more. Here's what's inside the ref. This is that format parameter that's in the path. It's required, but there's no default. You must specify it on every API call in this API. It's called format. It goes in the path. It's always required. It says what format the response should be. The example is JSON. It's a string. It can be JSON or it can be XML. So you get this very detailed description. If there are rules about data types, limits, length limits, integer ranges, negative numbers allowed, all of that goes here. We can describe all of those parameters in great detail. But what's nice about this is I didn't have to have these 10 lines in every endpoint in my spec. If we suddenly add support for protobuf, right? Whatever, I just add it here and then boom, it's everywhere. And that's really nice. I think OpenAPI is not just about publishing APIs, it's about maintaining them. It's about keeping everything in sync when we deliver all of these artifacts that relate to the API that we've built. Wow, you made it. Thanks for staying with me. That is a lot of YAML, and it's not always the easiest thing to work with, especially if you are new to this stuff. There are tools to help you. It would be much more sensible just to play you the video. So let's do a live demo. Let's have a look. Here we go. Cool. So this is Atom. It's just an ordinary editor. This one's from GitHub. It's cross-platform. I have got some YAML syntax highlighting plugged in. So that lets me see when I've made a syntax mistake. It'll put a little error if my indentation is incorrect. And I can expand and collapse things, which makes this a bit more readable, so I can just pop into the basic format. I also do a lot of find, like jumping to find. So I think the editor that you already have is a really good starting point because you're already expert in that editor. I'm a Vim user, and thousands of lines of YAML might seem ridiculous in Vim, but actually, I have syntax highlight, I have code folding, I drop a lot of marks. I'm pretty productive, really. I find it works pretty well. So you have some options. A really important thing here it is a text-based specification. You will not pass go or collect £200 until you have checked your spec into your source control system and you have committed often. Yes, I just stood on stage in a room full of tech experts and told them to use Git. I am not sorry. It's amazing. Like, we're firing all kinds of stuff off our Git commits because we can diff so easily. And when the version number changes, things happen. There's a whole separate talk, but just commit it to source control. You will thank your past self. There are also some dedicated, like, custom tools around. So, for example, this is Stoplight Studio. You're going to hear the word stoplight a lot. They're a company who offer a free desktop editor and also a web version of the same thing. They publish a load of open source tools around this space. They make money from selling you even more awesome things that you can pay for. But the entry-level things are available, so you can get started with this. There's no reason not to. I've turned up the font size, which has made the layout a bit less pretty than normal. But on the left, we've got the specs that are in my project. So that's a local Git clone. The changes that I make are just on my disk, and I can commit them back to GitHub in the usual way. There's a list of the endpoints that it knows about. In the middle, I've got this is the forms view. I like to think of it as the humans view. So this is where we can look at the different parameters and stuff that goes into this particular endpoint and drill into more detailed objects. Further over on the right-hand side, we've got the actual YAML that we're outputting, which can be quite useful to see. And also a list of validation errors or feedback. I've got some warnings here about tags. I think the big feature here, one of the reasons that brings people to Stoplight Studio and keeps them here is the validation. So it's quite nice to have it here, I guess, in the editor. We go here and drill down through the schema and say, oh yeah, this is within this file, and we can jump in and look what it is, look at the examples. Very nice. The validation that's happening here and on the web version is driven by an open source tool published by Stoplight called Spectral. So if you'd rather use your own editor, then you can just run that locally. Where's my slides? There we go. So here's Spectral in action. It's just wrapped in a shell script, so you'd have to watch me type. I've fed it that numberinsight.yaml file. As you can see, it's quite angry about very many elements of it. Spectral by default is opinionated. It is more than a validator, right? It's got lots of thoughts about what is the right way to do OpenAPI set. You can define your own rule sets. You can make additional rules of your own. So we have API standards, and they are written down. Before we release an API, a human reads the written standards and looks at the API and then says, oh, I think you've named that field incorrectly. Our rules that the things should be, I can't remember, maybe kebab case. I could automate that, and then we could have it on the build as we're working on new specs or on new features. So Spectral is the tool for that. I am always turning things on and off, so I just turn off these arguments about what data type my example should be. I mean, I'll fix it someday, but I haven't yet. And I don't want to see those build failures. So instead, I can run it here, Spectral lint, turning off a couple of those failing rules, and the path to the spec that I'm interested in. It detects OpenAPI 3 and shows me those 4 operation tags warnings that you saw in Stoplight Studio. So we can use whichever tools we want to. Here are the slides in the deck, so you can download this later and get all this again. Look, woo, Spectral. So that's great. We've figured out how to handle thousands of lines of YAML, how to validate it, how to style check it, how to wrangle it. It can be a bit verbose sometimes. We've explained our API. We've described it in great detail so that even the machines can understand what we've built. Yeah, so now what? What can the machines do for us? Now we've gone to all this trouble to explain our product to them. Well, we've got some options, and I'll start with the easy one, and that's documentation. Use your OpenAPI spec as the source of truth for your API reference docs. There's a choice of tools. There are a few commonly used ones, but there are lots of options. You can publish right out of Stoplight if you want to. One of the big open source tools is Redoc. We have our own at Nexmo. It's also open source, so you can use that if you want your reference docs to look like Nexmo. Because the OpenAPI spec format encourages, not just supports, encourages examples. It enables you to specify examples for individual fields, but you can also give a whole example response if you want to. It lends itself wonderfully well as a source for documentation. And because we're generating the output independently of the API description, you can output a bunch of different things. I mean, for the most part, we're going to output web HTML reference docs. Awesome. I've also output PDF ones from a top secret branch, which has a feature on that only very high-paying customers can have currently, because it's not scaled up enough. It'll be in the next version of the API. We don't want to publish that publicly because it'll confuse people who can't have it yet. So I generated PDF off my OpenAPI spec that time around. I've also seen some nice implementations that have like a cheat sheet. Doesn't show all the data that you've seen here. It just shows a list of endpoints and their supported methods and maybe a list of parameters, just to kind of remind you what you need to call here without having to wade through the whole thing. So you can take these specs and you can generate a bunch of different outputs. Let's look at some examples. So here's Redoc. It's a JavaScript tool, really well known. It looks like this. It just takes the spec and generates me some documentation. You don't have to do anything to get this other than write the spec and install the thing from NPM. It describes the endpoint. Here's the query parameters. Here's the response parameters. This is what the response looks like. Here it's using the individual example fields, the example values from all the fields to generate the response that you should expect. So instantly you can see what the payload would be coming back from this. I promised you more than one tool, so let's look at Nexmo's OpenAPI renderer. This is a Ruby gem that you can just install, either use it inside your Ruby application or use it standalone. Again, I'm not sure why we're opening in a new window today. Again, you can it generates this. Here's all the variables you can pass in. Here's the responses. You can see the example response on the right, looking terrible because I've turned up the font size so far. Look at it on your own monitor. It makes much more sense at a normal font size. One of my favorite things about this is it's so much more than documentation. I don't expect API providers to be like, well, we use OpenAPI, so we're awesome. I expect them to provide you that spec so you can be more awesome. So see the big download OpenAPI 3 definition button? This is where the magic starts. So we can download this file, and then we can use it in tools of our choice. My favorite example right now is Postman. There's a line around here somewhere. There we go. So I just downloaded that file, and I can import it into Postman. No, this button. This button. Excellent, there it is. Da-da-da. Awesome. So here is the number insight spec as a Postman collection. So I've got example requests saved in Postman for all of the endpoints that were in that API. So as a developer who's looking at a new API, or a stressed DevRel person who is unfamiliar with this product that I have to immediately provide support for, I'm sure I've seen this API before, but I forgot something, then we're here, and I can immediately start to play with it. So where's my API key? Here we go. We can just add some stuff and make some calls. This is my phone number. This is my country code. Postman does not correctly import multiple security schemes, so I'll just manually add the API secret, which is, of course, highly secure. If anyone sees me at lunchtime, please remind me to delete this secret off my account. Okay, and I would like that in JSON format. And you can see it building the query string at the top there. So if I send this request, I'm not on the Wi-Fi. Oh, come on. Wish me luck with the Wi-Fi. Imagine a wonderful response. Oh. Hotspot login is exactly what I need right now, thanks. But it's just logged in, right? I can just click through. Yeah. Awesome, thanks. And then here we go. That's the response for my lookup code. Yes, it's a valid number. It's a UK number. It looks like this. If you do the standard or advanced, then you'll get more detail. You can see which network they're on, whether they're roaming, whatever. So that's adorable. I travel quite a lot, and the thing with the Wi-Fi is not that unusual. However, I know exactly how this API should behave. I don't really need the live platform available to me. Also, my boss is getting tired of topping up my account because I'm always demoing something. So I can use a mock server that reads our OpenAPI description and pretends to be the server. We've described our fields, requests, responses. We've described how that should look, how to call it, what you should get back. So this is Prism. It's another stoplight tool. When it starts up, you feed it the file that you're interested in. That's a weird command because I'm running the bleeding edge because I'm testing something cool that they are making that is not released yet. First thing it does is output the endpoints that it understood from your spec. So that can be a really good start. Like, how are we doing? Oh, you didn't get them all. All right. And then it begins a server. So I've got this server running here on port 4010. And if I copy that link, I can just replace my base URL with that. And when I press send this time, Postman will just hit the local Prism server, and you can see immediately, oh, I got my sample responses. This is all Prism knows about. It's only got what's in the server. You can give it multiple one-of examples in the spec, so it will serve some different stuff, and you can specify, oh, I'd like the error one this time. It does a bunch of things. But for this, especially for library development, especially if the API is slow or expensive or annoying or, not shipped yet, then something like this helps enormously. And it's something that I'm finding just incredibly valuable. And if we go back to the console, you can see a request came in, this stuff happened, this is what I responded. So it's quite chatty, and it's something that you can use in your own work to develop against an API that isn't there yet, or that you can't call live, or it's just too slow when you're on airport Wi-Fi. All of those things. Right, so here are all the slides for the things that I've just said. Excellent. There's one thing that I'm not going to do live is a little bit slow and fiddly, and that is to generate an SDK. You can actually generate the API end, but I don't write that. I'm doing more SDK engineering right now. So, and I think it's something that's more applicable to us as developers, as consumers of APIs. And that's to generate the SDK. At Nexmo, we publish SDKs in, I don't think I'm supposed to say 7 different tech stacks. I think I'm supposed to say 6. It's 7. And I think that API provided SDKs will always be the best option. We have more than just API wrappers in our API, in our SDKs, in our client libraries. We have some message signing stuff. I mean, yeah, it's well documented. You can build it yourself. Don't, it's tedious. Some of the auth stuff has a couple of different steps to it. We wrap that up for you as a helper as well. So I think that'll always be the best option. Not every API provider can do this. Not every API provider has the tech stack that you need. If they publish you the OpenAPI spec, though, you can make a good start by yourself. So you can download that API description and generate some wrapper code that's going to call all the endpoints of that API. This one is the OpenAPI tools OpenAPI generator. It has a Docker container. It is basically idiot-proof. Um, it generates some admittedly slightly hairy code, but it works, and a README that says, copy this code and put your config here. So I copied this code and put this config here. I asked it for PHP. I'm not going to ask for a show of hands, but I know all of you have used PHP at one time or another. And I got this. So I wrote line 9, and the rest came for free, and this thing just works out of the box. This is awesome for getting started, like prototyping with an API that you don't know well. And I think a lot of the value here is in having the autocomplete in your IDE. Being able to be like, what are the endpoints? I need that one. Now it's prompting me for parameters. Okay, cool, yes, here is the country code. Here is the number I'm interested in, boom. It's ideal. And I think this generated code libraries is very interesting also for companies who do publish SDKs. I'm not sure there's any real value in publishing something that is just the generated code, except I guess you don't have to know how to generate it. You can just install it with the dependency manager. But I definitely would like to see more generated code with as kind of the model layer, if you like. This is also super valuable for the strongly typed languages, where you can just read off the spec how to deserialize the incoming JSON. Incredibly useful. But then also with some user-facing actual wrapper code that makes your API and the SDK that accompanies it more delightful. When things change in the spec, because APIs change, it'd be great if we designed an API, signed it off, shipped it, and that was the end of the story. My life doesn't work like that. Probably neither does yours. When things change, then we can regenerate the generated part and keep the separate user interface wrapper part, all the value add, all the extra helpers, and make it into one library. But it makes it really easy to stay in sync with changes. I've mentioned so many tools in this talk, and it's a tiny fraction. If you have a favorite tool, even worse if you're a maintainer of a favorite tool, and I didn't mention it, I'm really sorry. OpenAPI.tools is the place to go to find out what the tools are for the thing that you want to do, probably in the tech stack that you're interested in, for the version of OpenAPI that you want. Spoiler, if it's not version 3, then you can start with the conversion tools that will just update your spec for you. And then you're all good to go, and we can all stop saying the word Swagger till the end of time. There's a bunch of tools here, so many that I contributed this table of contents added thing because I couldn't find anything. It was in sections, but there was no way to find the section that you needed. I think I have been speaking on this topic for more than a year to a variety of audiences. In that time, the tools space has transformed beyond recognition. We've gone from, oh yeah, we have one documentation tool that works really well and some rumors of other stuff that works for a small number of specs, to this enormous list of incredible, useful, robust tools, and they're all open source. It's an open standard. We're building in the open. We're learning, sharing, building upon each other, integrating with the existing tools. You know, people build a validator. They integrate with an existing docs tool so you can render and preview your changes. It's an exciting time. And that means, for anyone watching this on the video, whatever I said is probably out of date. You should check this site. It's also, again, the site is open. So if there's a tool that's not here that either you create or that you know about, then you just open them a pull request. They're good people, and they'll review it and get it added. So this is very much a community effort to try to keep it up to date. There might be something that's marked as not having complete support. If you know that it does, you know, help us keep that information up to date, because it's our go-to place for finding the tools that are available to us as a community and the things that we can do. OpenAPI, I think, changes a lot of things. I think it flips our understanding of where the changes start. Lots and lots of organizations are still generating their OpenAPI spec from their code, and that's a valid approach, of course. Every scenario is different. But I think the value in beginning with the spec, being able to involve everybody from the very beginning to just prototype ideas. Changing a spec is cheap, right? I can do it. Anyone can do it. It's the equivalent of an Excel spreadsheet, right? It's super accessible. It doesn't cost anything to change at spec stage. We haven't built anything yet. But we can look at it, we can try it out, we can test it, we can render the docs, we can run them past people, we can kidnap potential customers and ask them to give it a go, right? It's an incredible way to lead API change. And I think that's what makes OpenAPI really well suited to our more long-lived applications. I've been in web development long enough that at one time we built a website for a company, and 2 years later they'd need a new website, and we would do them our project, and the website would be finished, and it would ship, and then that would be it, and then we would just replace it. And our APIs have looked a little bit like that too. They don't have to, and I don't think we build software like that today. We build it intending to last, intending to have a future, intending to be maintained, and have changes and grow over time. By leading with the OpenAPI spec, we ensure that we can keep everything we do in sync. So we have the spec, we can generate the code stubs for the API, we can generate the SDKs or parts of them perhaps, we can have documentation up to date, we can know that the expected response from this API has changed, maybe it has an extra field, we can update all of our tests for our SDK libraries. Like, there's so much we can do when we treat our API description as a first-class citizen, when we make it the beginning of everything, because everything can be connected to it. So as one thing, and it might be something super small. We had an incorrect data type in our spec because they're all retrofit, so there was a place where it was documented as an integer, and actually it comes as a string, and it was tripping up one of our strongly typed languages, and it was like, we're able to go back and fix that and get that same, it wasn't causing a problem in the other tech stacks, but it's now correct in all those places. Because it's very easy to propagate, very easy to keep track of what's changed. And I think that will make an enormous difference to the way that we are able to, first of all, consume APIs, right? I'm a consumer first. And to be able to just grab a spec and quickly explore an API, that's magic. And I use it on APIs I should know really well as well. There's such value there. But also in the way that we publish APIs, the way that we run our APIs as really serious software projects, not as things we bolted on the web server later. I think this is really key, and I think you'll see more of it. When you're researching APIs, look for the ones that have the spec for you to download. Grab it and see what you can do with it. If you are an API publisher, then could you describe your API? How would that look? What would you do with it? The possibilities are endless, and I think it's a super exciting time to be working in this space. I have a bunch of resources for you, and hopefully my Twitter account will tweet that at some point. I've also really like to just remind everyone who might be tired of the novelty of the app by now, as you've been here a couple of days. Just drop in, tell me what you liked and what you might change, because I might give this talk again. So that'd be really useful. And yeah, I've got some resources. I'll leave them on screen. I'm really conscious that you probably all want to go to lunch. So I will hang around for a bit, take any questions you have. But apart from that, thanks very much.